This video is on set theory symbols and definitions. This is the first page of set theory symbols and definitions. We're going to only talk about a few of the words on here because those are the ones we're going to talk about for this level of math. The first one we're going to talk about the symbol and the name. We're going to have symbols, names, the definition, and an example of them. First one is called a set. A set is notated with the two brackets. They're the squiggle brackets. A set is a collection of elements. This first one is used throughout this entire video. A collection of elements, that means that anything inside of the set, this could be a number, it could be a letter, it could be an object, it could be a name, it could be a month of the year. So an example of this is A equals, so set A equals. Then what we have is the brackets, and we have 2, 7, 8, 9, 15, 23, 35. This is just an example of a set. It contains all of these numbers in it, and then when it ends, we close the bracket. Now we do go in order from least to greatest. We always try and go in order from least to greatest for that set. So set A is equal to 2, 7, 8, 9, 15, 23, and 35. It doesn't say anything in between them, so number 5, or value 5, would not be a part of this set. The next one we're going to talk about is intersection. The symbol for the intersection is this in shape. What this says is that objects that belong to set A and set B. So this and part is what's important. We have set A intersect set B. We want to see what belongs in A and also in B. What that means is that we want the overlap between them. The overlap. So if I have set A is 1, 2, 3 and set B is 2, 3, 4, the intersection of A and B, so again, and A and B, is what numbers overlap on these two. So numbers 2 and 3 will overlap. So technically the intersection of A and B is equal to 2, 3. Because intersection is what is in both of them. The next one is union. Union is objects that belong to set A or set B. The symbol for union is a U shape. So it's A union B. So if we have set A is 1, 2, 3 and set B is 4, 5, 6, we want everything that's in set A or in set B. What that means is we take everything that's in set A and we write it down. We then take everything that's in set B and write it down. So the union would be 1, 2, 3, 4, 5, 6. If there is an overlap of a number, we do not write it twice. We only have to write it once. So if they had overlapped at 3, we would have written just 1, 2, 3, that 3 one time, and then 4, 5, 6. So if I come back up here, if I wanted to say the union of these sets up here, I see 1, 2, 3, and then 2, 3, 4. So the union of these two sets would be 1, 2, 3, 4. I do not have to write the 2 and 3 again because it's already stated once. So you gotta see the difference between the words and or. The or is, if you can write it, you write it. Anything that's in it, you write it down. The and is, it has to be in A and also in B for us to write it. So we can't just write down a number 1 up here because it's not in set B. So an and has to be in both. Or has to be in one or the other. If I have a number from here, it's good. If I have a number from here, that's good as well. The next one we're going to talk about is subset and proper subset. They go hand in hand with each other. The definition of a subset is that set A is a subset of set B if and only if every element of set A is in set B. So everything that's in A, so A, B, C, have to be included in set B. As you can see here, set B is also A, B, and C. This symbol is a sideways U with a line underneath it. The proper subset is just the sideways U, or it's the C almost. The difference between the subset and proper subset is that in a proper subset, all of the set A is inside of set B. However, set B has at least one thing extra. So set A has A and B. Set B has A, B, C, and D. Because it has that C and even the D, this makes it a proper subset. Now these words are almost interchangeable. You need to see that the equality part here states that set A is the exact same as set B to be a subset. I'm going to be using subset interchangeably. It just means that all of A is inside of B. When I'm talking about subset, it means that A is inside of B. The next one, and the last one on this page, is the not a subset. The symbol for not a subset is the subset symbol with a slash through it, almost like an equal sign with a slash through it means not equal. This means that subset A of not does not have any matching elements of set B. So set A and set B do not have anything matching together, so they would not be subsets of each other. The other words on here would be superset, proper superset, not a superset, power set, and equality. We're not going to be focusing on these words. On the second page of set theory symbols and definitions, we're going to be talking about a few of these. The first one is the complement. Complement. This is denoted by A raised to almost like a C power, or it could look like A almost prime. This states that all objects that are not in set A. So we will look at this again when we look at another set. It's anything that's not in set A. So if it says A complement, it's everything not in A. If it said F complement, it's everything not in F. So whatever the set is attached to is the set we're talking about that it's not in. We're going to skip over these two. We're going to go down to element of. Now earlier I said that a set is a collection of elements. So an element, the symbol for element is this little E. It's almost like that subset symbol with a hyphen through it. So it's a weird shaped E. But notice it says little a, and it has that E symbol and then big A. This states that A, little a, is an element of set A. Means that it has a membership of set A. So if set A is A, B, E, F, G, H, then little a is an element of big A. We're also going to talk about not an element of, so the same thing as before when I said the symbol with the slash through it. So this is an element symbol with a slash through it. It says X is not an element of set A. So it's not a member of set A. Again, if set A is A, B, E, F, G, H, then X is not an element of set A. We're also going to talk about the null or empty set. It's a 0 with a slash through it. States that this set does not contain any elements. You'll see this a lot when you're looking for an intersection and there's nothing that overlaps. So if set A is equal to just a blank bracket, then set A is equal to the null set or the empty set. Again, this happens more often when you're talking about intersections and there are no overlaps. The next one is the universal set. This is noted with a U, but it has the two lines on top of them. This is a set of all possible elements. This is basically a bunch of unions together. And I'm going to talk about this and go back to complement in just a moment. So the universal set, when we look at the universal set, set A is 1, 2, 3, B is 4, 5, 6, and set C is 7, 8. Universal set is everything that is in any of these sets is in the universal set. Again, we only write the number once, so if it overlaps, we don't have to write it twice. So we put in the universal set, the 1, 2, 3, 4, 5, 6, and the 7, 8. So all of these are in there. Now, I want to go back to complement for a second and explain that when we're saying all objects that do not belong to set A, this goes from the universal set. So if my universal set is 1, 2, 3, 4, 5, 6, 7, 8, and I want a complement, I want all the numbers that are not 1, 2, 3. So I would say these are gone, so my A complement would be 4, 5, 6, 7, 8. I can do the same thing with B complement, which I want everything not the 4, 5, and 6. So B complement would be 1, 2, 3, 7, 8. Is anything from the universal set that is not in the individual set of A or B or C, whichever one it's talking about. So if it says B complement or C complement, we want the ones that are not in those individual sets. The next one is the set of natural numbers with 0. The set of natural numbers with 0. Another word for that is a whole number. Those are whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, so forth and so on. So it says 0 is an element of the whole number. So that is that fancy n with the 0 subset of, or a sub of 0, because it's saying that it does include the 0. The next one is the set of natural numbers without 0. These are just what we call the natural numbers. Natural numbers are your counting numbers. These are counting numbers. So 1, 2, 3. So no fractions, no decimals, and no zeros. So the whole numbers are your counting numbers, are your natural numbers, but it includes 0 as well. The next one is set of integers. So this fancy Z are your integers. These are all positives and negatives and 0. This does not include decimals or fractions. It's all of your counting numbers plus the negatives of them and your 0. So all of your whole numbers and the negatives. The next one is the set of rational numbers. This is a fancy Q. A rational number is a number that can be expressed as a fraction where P and Q are integers and Q does not equal 0. What this just means is a set of rational numbers are your fractions, your positives, your negatives, your zeros. You still cannot divide by 0. This is what that means. Where P and Q are integers, it's a fraction. P over Q. Q cannot equal 0 because you cannot divide by 0 anytime. So this fancy Q is a set of rational numbers. Rational numbers are anything that can be written as fractions. So 0.6666667 is really 2/3. So anything that can be written as a fraction. This next one is this fancy R. It stands for the set of real numbers. Real numbers are anything that goes from -infinity to infinity. So this can be fractions, whole numbers, zeros, negatives, decimals, anything that is real. So any number can be a part of the real number system. The last one is the complex numbers. This is that fancy C. Now the difference between the real and the complex. Complex has the imaginary. That's what this is saying. That Z is equal to A plus BI. So we can have from -infinity to infinity on both the A and the B, but you have to have the imaginary part to become a complex number. So this is why 5 plus 3i is an element of the complex numbers. If it was just 5 plus 3, that'd be 8 and it'd be real. But because it has the imaginary I part, that was that square root of a negative number. It's like the square root of -36 is 6i. This goes back to imaginary. Complex is another word for imaginary. So I'm going to write that in here. Imaginary. That's what that one's talking about. Complex is imaginary. So these are the words we're going to be focusing on, and we're going to do more examples of these.